Alrighty, so for sequences, explain the difference between arithmetic and geometric sequences. So just arithmetic has to do with sequences that are addition or subtraction. Geometric are going to be division or multiplication. Explain the difference between the recursive and the explicit formula. When would you use each? So for the recursive, this is to find the next term. For the explicit, this is to find any term. I'm actually going to write out the formulas just so we gotta remember what they are. First I'll write the arithmetic formulas. And then first I'll write the recursive. You need to state the first term, whatever it is. And then to find the next term, you use the previous term and you add the common difference. So remember, D is for common difference. I'll write that here, common difference. And we use the letter D. The explicit is to find any term. It's going to be the first term plus n minus 1 times D. And then the geometric formulas. The recursive formula is state the first term, whatever it is, and then to find the next term, you use the previous term and you multiply by the common ratio. Okay, so for geometric, the pattern is the common ratio, and you use the letter R. And the explicit formula for a geometric sequence is a sub n is equal to a sub 1 times r to the power of n minus 1. And then we're going to see some examples below. So for each situation here, write the explicit rule, the recursive rule, and then find the 27th term. Okay, so the first term is 7, common difference is negative 2. So I'm going to start with the recursive. We're going to state the first term, which is, they're telling us here that it's 7. And then to find the next term, it's the previous term plus the common difference, negative 2. The explicit, a sub n is equal to first term, which is 7, plus n minus 1 times the common difference of negative 2. And then the 27th term, I'm going to use the explicit formula and I'm going to substitute into it. So a sub 27 is 7 plus 27 minus 1 times negative 2. Okay, so I'll go punch that into the calculator. 7 plus 27 minus 1 times negative 2. And that's negative 45. Okay. For number 2, a first term of 2 and then a common ratio of 0.4. So that one, since we have a common ratio, it's going to be geometric. So once again, the recursive formula, state the first term, to find the next term, use the previous term, and you multiply by the common ratio, which is 0.4. For the explicit, it's the first term, 2, times the common ratio, 0.4, to the power of n minus 1. And then the 27th term, 27 is 2 times 0.4 to the power of 27 minus 1. You can simplify it to 2 times 0.4 to the power of 26. So this is going to be a very small number. To the power of 26. That's a very small number, so your answer is in scientific notation. So you could actually leave your answer like that. It's fine. Okay, number 3. This time you're actually given the pattern. You need to figure out what's the common difference or the common ratio. So for number 3, I could see to go from 1 to 3 to 5 to 7, I'm adding 2. So this is arithmetic. So make sure you use the arithmetic formulas. Okay, so for the recursive, the first term is 1. And to find the next term, you use the previous term and you add the common difference, 2. For the explicit, it's the first term, 1, plus n minus 1 times the common difference, which is 2. And then for the 27th term, be the first term plus 27 minus 1 times 2. Okay, so 27 minus 1 is 26. 26 times 2 is 52, and then plus 1 is 53. Okay, or use your calculator. And then finally here, the pattern, -2, 4, -8, 16. Well, if I ignore the negative signs, I see that you're multiplying by 2. But to go from positive to negative, that means you need to multiply by -2. Okay, so that's the pattern. So if it's multiplication, make sure you use the geometric formulas. So for the recursive, the first term is -2. Okay, to find the next term, you need the previous term, and you multiply by -2. For the explicit, first term is -2. Common ratio is also -2 to the power of n minus 1. And then the 27th term, plug in 27 into the exponent. I'm going to use the calculator for that. So this is actually -2 times -2 to the power of 26. Okay. All that will give you this big number here. Negative 134,217,728. Big number. Okay, that was a quick review of sequences. Next, we're going to review rationals. So, excluded values. How do you find excluding values? You find values that make the denominator 0. Okay, you're going to exclude these values because you cannot divide by 0. So the denominator is not allowed to be 0. Explain how to multiply and divide rational expressions. Okay, you're going to factor, then cancel when necessary. And I'll show you some examples below. And then explain how to add or subtract rational expressions. So same way you add regular fractions, you need to find the LCD, find the least common denominator. Okay. Practice problems here. So this one is just a solving problem. When you have a fraction equal to a fraction, you could always cross multiply. So if I cross multiply, you get -2 times x plus 1 is equal to 5 times x plus 3. I could use the distributive property here on both sides. So -2x minus 2 is 5x plus 15. I'm going to add 2x on both sides. So -2 is equal to 7x plus 15. Okay, I'm going to continue up here. I'm going to subtract 15 on both sides. So -17 is equal to 7x. And then divide both sides by 7. So -17 over 7 is equal to x. Okay, so just make sure you cross multiply first. Okay, find excluded values for this problem. Remember, that's when we're going to find values that make the denominator 0. So here, what we're going to figure out what makes that 0 and what makes that denominator 0. Start with the easy one, the x minus 7. So we need to figure out when that is equal to 0, and you just solve for x. So if I add 7 to both sides, x is equal to 7. So here is one of the excluded values when x is 7. Now the other one, x squared minus 7x plus 10. We need to figure out when that is 0. To do that, we did what we did in chapter 4. We're going to factor this quadratic. So what number should multiply to 10 and add up to -7? Five and 2. But to get -7, they both have to be negative. So x minus 5, x minus 2 is equal to 0. The x value that makes this 0 would be 5 and 2. So these three numbers, 7, 5, and 2, are the excluded values. Okay, next, we're going to simplify this here. So what we're going to do is we're going to factor this here to help us simplify. So x squared minus 16, you should recognize that this is a difference of squares. So this actually simplifies to x minus 4 and x plus 4. The square root of x squared is x, and then the square root of 16 is 4. So that's how we got that. This is a difference of squares. So I'm going to replace what I highlighted. Hold on. It's kind of frozen. There it is. I'm going to replace what I highlighted with this expression here. So I'm going to rewrite this. X minus 4, x plus 4, x plus 2 over x plus 4 times 4x plus 4. Okay, now that I factored it, I'm going to find something that I could cancel. It has to be the same on top and the bottom. So since we have both, we have both an x plus 4 on both the top and the bottom. Oops. You can go ahead and cross those out. So now the simplified version is it's x minus 4 times x plus 2 over 4x plus 4. Okay, that's one way to simplify it. Factor it and then cross out any values that you see. The same on top and the bottom. Okay, and then last one here, solve and state the excluded values. So remember, the excluded values is when the denominator is 0. So there isn't any variable in the denominator, so this one actually doesn't have any excluded values. Okay, so, but we could still solve for n. So what I'm going to do first is I'm going to distribute into the parentheses. So that turns into 4 minus 1 plus 3n over 36 equals 2n minus 6 plus 7 over 12. I'm going to combine like terms. So 4 minus 1 is 3. And negative 6 plus 7 is 1. Now I could actually cross multiply. So 12 times 3 plus 3n is equal to 36 times 2n plus 1. Cross multiply, then do it like the problem above. Okay, now I could distribute again. 12 times 3 is 36 plus 36n, because 12 times 3n is 36. 36 times 2n is 72n plus 36. Okay, I'm going to bring all the n's on the same side, so I'm going to subtract 36n on both sides. Okay, so that leaves me with 36 is equal to 36n plus 36. I'm going to subtract 36 on both sides. So that leaves me with 0 is equal to 36n. So if I divide by 36, n is also equal to 0. So all that works so we can see that n is equal to 0. Questions on this one? Okay, we can continue here. Concept 9, systems of equations. Describe all possible solution sets for a linear or linear system of equations. So for linear on linear, so we have two lines. Like here, we have one solution. you have parallel lines that never touch, there's no solution. Or if you have a line, it's kind of frozen on me. There it is. A line on top of another line, so that green line on top of that highlighted blue line, this is actually infinite solutions. Describe all possible solutions for a linear quadratic system of equations. Okay, so you could have a quadratic and a line going like this. So you could have two solutions. You could have something that looks like this that only intercepts once. That is one solution. You could also have something that looks like this where they completely miss each other. So that's going to be one solution. Describe the three methods for solving system of linear equations. Okay, so the three methods are by graphing, by substitution, and by elimination. And I'll show you some examples below. Describe what it means to be a solution set to a system of inequalities. This is when you shade a region. So system of inequalities could look something like this. And then only one region is actually the solution. And you have to like color it in. So that's when you shade a region. Okay. All right, so let's solve these problems here so we can see what we're talking about. Solve the system here using any method. Okay. So we have a quadratic and a linear. So I'm going to add these equations to each other. So if I add them to each other, let's say, so if I add x, oops, let me change to my marker. So if I add these together, you have x squared plus 7x, I'm sorry, plus 8x sorry, let me start all over. This thing's freezing on me. I'll just write over here on the other side. So the solutions are when the equations are equal to each other. So when is x squared plus 7x plus 10 equal to x plus 5? Okay, so I'm going to subtract x on both sides and subtract 5 on both sides. So now we have x squared plus 6x plus 5 is equal to 0. Okay, so to solve this, we're going to factor. Numbers that multiply to 5 and add up to 6 are going to be 5 and 1. So the factors are x plus 5, x plus 1 is equal to 0. And then the numbers that make these 0 are going to be negative 5 and negative 1. Those are the x values. Now that I have the x values, I'm going to substitute the x values into the equation here to get the y values. So if I substitute negative 5, you get 0. So negative 5 comma 0 is one answer. And if you substitute negative 1, you get 4. So negative 1 comma 4 is the other answer. I'm going to verify this by actually graphing it. So if we go to decimals, type in both equations. Squared plus 7x plus 10. We could see here that the line intersects here at negative 5, 0 and negative 1, 4. So those are the 2 points of intersection, those are the 2 answers that we got. That was number 1. Number 2, y equals negative 1/2 x plus 3 and 5x plus 2y is equal to 10. I'm going to solve this one by substitution. Since I know what y is, I'm going to substitute it in here for the y value. So 5x plus 2 times negative 1/2 x plus 3 is equal to 10. Okay, I substituted the y value. I replaced this y with all of that, which is this part here. Okay. Now I'm going to distribute to make this a little simpler. So 5x. So negative 1/2 of 2 is going to be minus x, and then 2 times 3 is 6. So this simplifies to 4x plus 6 is equal to 10. If I subtract 6 on both sides, 10 minus 6 is 4. And then if I divide both sides by 4, that means that x is equal to 1. So now that I know that x is equal to 1, I could find the y value by substituting it into the formula up here. So y equals negative 1/2 times 1 plus 3. So y is equal to negative 1/2 plus 3, which is 2.5 or 2.5. So the solution is 1 comma 2.5. Again, I could verify it by graphing it. So y equals 1 over 2x plus 3. And then the other equation was let me find it again. 5x plus 2y is equal to 10. And we see here that it intercepts at 1, comma 2.5, which is what we got here. Okay. And then the last one, y equals y is actually less than negative x plus 5, and 2y minus 4x is greater than or equal to 8. So inequalities, you need to graph them, and you want them in slope intercept, like this first inequality here. So that one's actually okay. This one over here on the right, we need to solve for y. So I'm going to add 4x on both sides first. And then I'm going to divide everything by 2. So now you could actually graph these. So use this graph paper down here. And then 1, 2, 3, 4. All right, so for the first one, the y-intercept is actually 5, so it's actually up here. And it has a slope of negative 1. So down 1 over 1, down 1 over 1. And since it's less than, it's going to be a dashed line. So I'm going to shade below. This is less than. And now in green, I'm going to graph the other one. The y-intercept is 4, and then up to over 1. And since it's greater than or equal to, this is going to be a solid line. And I'm going to shade this one in green. Okay. So your answer is the shaded region here, where both of the colors intersect. See down here, you only have blue, and then right here in this little corner, you only have green. Your answer is where both colors intersect. Questions on that? Okay, and then this is the last chapter of the school year that we're going to review. Okay, explain how you build a box plot. First, you need to arrange the numbers from least to greatest. Okay. Then you're going to find the median, the minimum, which is the smallest number, the maximum, which is the largest number, the lower quartile, and the upper quartile. Okay, so let's do that here with these. So we're going to find a box plot with the set of data here. Okay, so first just put them in order. Smallest number I think is 34, and then 37, 41, 42, 46. There's two 49s, 50, 51, 52. Okay. Okay, let's find the median first. So I'm gonna work my way to the middle. All right, so I have two numbers in the middle. So the median is gonna be 46 plus 49 divided by 2. So 46 plus 49 is 95, and then divide that by 2 is 47.5. Okay, so the median is here, 47.5. We're going to ignore the median to find the lower quartile. So we're going to find the middle. Sorry. We're going to find the middle of these numbers here. And then the middle of these numbers is 41. That's the lower quartile. And then the middle of these numbers is 50. That's the upper quartile. And then the minimum is 34 and the maximum is 52. Okay. So let's build a number line from 34 to 52. So this, let me say this is 30, this is 40, this is 50. And then we're just gonna approximate. This will be 35 and this will be 45 if you want to get a little bit more detail. Okay. Smallest number is 34, which is about here. And then the lower quartile is 41, which is about here. The median is 47.5, which is here. Upper quartile is 50, and then 52 is our max. So there's our 5 numbers that we need. This is a box plot, so you're going to put a box in the middle, and then draw a line where the median is at, and then extend it to the minimum and maximum value, and you have your box plot. Okay. Last one. Find the mean and standard deviation of this data set. So we're gonna need, first we need to add up all the numbers and divide it by how many numbers we have. Plus 7, plus 7, plus 6, plus 7, plus 7, plus 6, plus 4, plus 7, plus 5, and plus 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10. Okay, so let me use the calculator so I can keep track of this. Okay, so let's see. 7 plus 7 plus. Okay, I got 60. And then 60 divided by 10, I got 6. So this is the mean. And the symbol we use for mean is X bar. Okay. And then to find the standard deviation, you need to make that table that we worked on. So all the X values go first. Seven, seven, six, seven, seven, 6, 4, 7, 5, 4. First, we're going to subtract the mean from each one of the numbers. The mean is 6. So 7 minus 6, 1. 6 minus 6, 0. Okay, so I subtracted 6 from each one of the numbers. Then each number in that second column, you're going to square it. You're going to multiply it by itself. So 1 squared is 1, 0 squared is 0. Negative 2 squared, that's 4. And another 4 at the end. Okay? Now, standard deviation is the square root of the sum of all the differences squared divided by n. So what all of this here means is that we need to add all these numbers. Okay, so 1 plus 1 is 2, 3, 4. 4 plus 4 is 8, 9, 10. 10 plus 4 is 14. So the sum of all of those numbers is actually 14. Sorry. It's a little lag with my computer here. There it is. So I'm going to replace what I highlighted into the formula. There it is. So the square root of 14 over how many numbers we have. N is how many numbers we have. We had 10 numbers to start with. And then we can use our calculator to find out what that is. So the square root of 14 divided by 10 is 1.18. And that's your standard deviation. Alrighty, so we're at the end